There's this incredible material that is quietly but completely changing the game for electric cars. It's the reason they can go farther, charge way faster, and, believe it or not, might even start costing less than you'd think. Look, the EV revolution isn't on its way. It is here, right now. All the big automakers are pouring billions into an all-electric future, and you can see it in the sales numbers, which are just exploding year after year. So really, the question isn't if we're all going to be driving electric, it's just a matter of how soon. But with all that momentum, what are the things that are still giving people pause? What are those big roadblocks we have to clear before everyone is ready to make the switch? Well, it pretty much boils down to these three things. First, you've got range anxiety, that nagging fear that you're going to run out of juice. Second, there's the sticker price, the upfront cost of buying one. And third, nobody wants to wait around forever for the battery to charge. These are the big puzzles that car companies are in a mad dash to solve. And this is where it gets wild. A huge piece of that puzzle, a massive part of the solution, comes from a tiny, tiny chip. And this chip is made from a material that was first discovered in a meteorite, a material that is literally older than our own solar system. And it's called Silicon Carbide. So, what in the world is this stuff? Let's get into it. Okay, so silicon carbide, or SiC for short, is basically what you get when you combine silicon and carbon. But the result is this semiconductor material that is just absurdly tough and efficient, especially when you're dealing with the kind of high power and intense heat that's cooking inside an electric vehicle. Now, SiC has a secret weapon. It's something called a wide band gap. All you need to know is that the band gap is the amount of energy it takes to get electrons moving and create a current. And here's the kicker. Silicon carbide's band gap is almost 3 times wider than the good old silicon we've been using for decades. The easiest way to picture this is to think of a hill. Regular silicon has a pretty small hill to climb, but SiC, it has a massive hill, and that bigger hill means it can take so much more punishment, way more energy, much higher voltages, and crazy temperatures before it even thinks about breaking a sweat. It's just built different. It's fundamentally tougher. And that toughness creates this amazing chain reaction of benefits inside an EV. Because it can handle the heat, you don't need as much clunky cooling equipment. Because it can handle crazy high voltage, you suddenly unlock things like 800-volt charging, which is how you get those super fast charge times. And because it switches on and off so quickly, all the other components around it can get smaller and lighter. It's just a win-win-win. Okay, so we've established that this material is incredibly tough, incredibly efficient, so let's look at what actually happens when you put it inside an EV. This is where it gets really good. You'll find SiC right in the guts of an EV's power system. The big one is the inverter. That's the brain that takes DC power from the battery and flips it into AC power to spin the motor. But it's also crucial in the onboard charger and the DC to DC converter that powers your radio, your lights, all that stuff. In every single one of these jobs, losing less energy to waste heat, being more efficient, is the name of the game. So all this talk about efficiency, what does it actually get you in the real world? Well, just by swapping out the old silicon inverter for one made of silicon carbide, automakers can boost an EV's driving range by 5 to 10%. That is a huge leap in performance from just changing out one little component. All right, so you're probably thinking what I'm thinking. More range, better performance. This thing has to make the car more expensive, right? That's just how it works. And this is where the whole story takes a fascinating turn. The answer is not really. Because SiC is so much more efficient, car makers realize they can hit their target range, say 300 miles, using a smaller battery. And when you remember that the battery is by far the most expensive part of an EV, sometimes a third of the car's total cost, making that battery even a little bit smaller saves a ton of money. This chart really breaks down the new math. So yeah, this SiC inverter chip itself costs more than the old silicon one. But, and this is the important part, the money you save by using a smaller battery can completely wipe out that extra cost, and then some. It can actually make the total cost of building the car go down. It's a perfect example of a smart investment paying for itself and more. It's this powerful cost-benefit math that explains why the auto industry is betting the farm on silicon carbide. So let's just take a look at how quickly this is all happening and what's coming next for this incredible technology. The adoption rate has been just breathtaking. Tesla really kicked things off back in 2017 with the Model 3. Fast forward to 2021, and you've got giants like Hyundai, Kia, and BYD all shipping cars with SiC. Just last year, SiC was in over a quarter of the entire EV inverter market. And the tech itself isn't standing still. It's getting even better and cheaper. Now, feeding this massive appetite for SiC means building a whole new supply chain, and it is a complex journey. You start with these raw powders, you have to grow these perfect, massive crystals, slice them into wafers, and then finally turn those into the finished chips that go into a car. It's a huge industrial effort. The single biggest challenge is still the cost of making those flawless crystals. It's not easy, but the industry has a clear roadmap to make it cheaper. They're moving from smaller 50-millimeter wafers to bigger 200-millimeter ones. It's like going from a personal pizza to a large one. You just get way more slices, or in this case, chips, out of each one, and that brings the cost per chip way down. So it's safe to say that for those really demanding, high-power jobs like the main car inverter, silicon carbide is absolutely the king of the hill right now and for the foreseeable future. But you know how technology works. The search for what's next never stops. And while SiC is wearing the crown today, there's another material stepping into the ring, gallium nitride, or GaN. So how do these two stack up? Well, think of it like different tools for different jobs. SiC is like a sledgehammer. Its raw toughness is perfect for the brutal, high-voltage world of the main inverter. GaN, on the other hand, is like a surgical scalpel. It can switch even faster than SiC, which makes it a rock star for lower-power tasks like the onboard charger. So it's not really going to be SiC versus GaN, it's going to be SiC and GaN working together as a team to make the whole car smarter and more efficient. You know, this quote from one of the pioneers in the field, John Palmer, just nails it. He said, "You can make the device in silicon carbide that you really wanted in silicon, but due to the physics of silicon isn't practical. It just lets engineers break past old limits." So in the end, the future of driving isn't just about packing in bigger batteries. It's about being smarter with power, right down to the atomic level. And that leaves us with a really interesting choice. As these incredible materials get even better, do we use that efficiency to make EVs with 500 miles of range? Or do we use it to make cars with smaller batteries that are affordable enough for everyone? That's the battle being fought right now, on a scale you can't even see.